Welcome back, pre-calc students. This is Mrs. Spellin here. We are on Unit 1, Lesson 4. So we are graphing sinusoids, which basically just means we're graphing sine and cosine functions. So I wanted to go over the basics of how we graph a function that might have an amplitude change, could have a period change, could also be shifted left, right, or up and down. So we talked about this last year in Algebra 2. You've talked about a lot of other kind of functions that kind of follow the same pattern with the h and the k. I'm just going to kind of specifically go over how to graph a cosine or a sine function regardless of the transformations. So my first step, what I'd like to do is I find the period of the function. So in order to do that, we have to use that formula to help us figure out the period of the function. So for sine and cosine, it's 2 pi over b. So remember, b is in our equation, that's the number being multiplied by x. It's your horizontal or stretch or shrink. Step 2, we're going to use that period. So using the period, I want us to label the x-axis. So if you remember, we talked a lot about this last year, at least in my classes, I talked a lot about the 5 key points. And so we're going to use whatever we get for the period here kind of dictates what scale we're going to use on our x-axis. Next, I'm going to say we want to plot the midline. So remember, the midline is not really like an actual part of the graph, but it helps us because what the midline does is talks about the vertical shift, so up or down. So what the midline is going to do is kind of tell us our k value. So if this were like +3, that means the whole graph is shifted up 3. If it was -2, it'd be shifted down 2. And so it's symmetric around the midline. So there's like equal parts up as there are down. So if we know the k value, we know the midline of that value or of the function. Once we know the midline, we can use the midline to help us figure out the min and the max. So I'm going to put find min and max. So if you remember with a cosine function or a sine function, it kind of goes up to a max and then down to a min or vice versa. And so we're going to find the min or max using the amplitude. I want you to label your y-axis. So, for example, if the amplitude is 4, that means from the midline you would count up 4 for your max, and then from the midline you would count down 4 for your min. And then last but not least, you're going to follow the pattern. So you're going to follow the sine or cosine pattern that we kind of talked about last year, and then you're going to connect your points in a smooth, a nice smooth curve. So the pattern is, if you remember for sine, it's always starts at a midline, so it goes midline max, midline min, midline. For a cosine, it starts at a max, and it goes max, midline, min, midline, max. So you can look back probably at your notes last year, and you can probably see some of the stuff that you guys did. So graphing sine and cosine are really kind of the same idea. It doesn't really matter if it's sine or cosine. The only thing that changes is kind of when it gets down to the bottom, like where you actually plot your points. And that's pretty much the only step that changes. Okay, so let's go ahead and start. So the first thing I want to do is find the period of my function. So I'm going to take the 2 pi over b. So I'm going to do 2 pi over b. B in my particular example is the number being multiplied by x. So the number being multiplied by x is 4 pi. So don't forget that the pi and the 4 are both numbers. So I'm going to reduce this to 1/2. So using that period, what I'm going to do now is label my x-axis. So I pick some distance that is, that I can maybe a little bit further, you don't want it to be too close because you want to be able to see your values. And then you're going to always start, I always start forward, and then whatever the period is kind of where I place this last point. We're going to have the whole graph kind of fit within this range. So then you're going to do the halfway point. So halfway between 0 and 1/2 is a 1/4. And then you're going to do the quarter points, or half of a half. So halfway between 0 and a 1/4 is an 1/8. And so now you can see you're counting by eighths. So 1/8, 2/8, this would be 3/8, 4/8, 5/8, 6/8, and so forth. All right, so we got the first two steps done. Number 3, plot the midline, which is your k value. So our k value in our equation here is -3. So I'm going to go ahead and 1, 2, 3. I'm going to go ahead and use, I'll use a line for our k value, or for our midline. I always use a dashed line because it's not part of our graph. It's like, it just helps us graph. So I'm going to go ahead and label that down there at -3. And then I'm going to use the amplitude. So it says plot the midline, then it says find the min and max using the amplitude and label your y-axis. So our amplitude is the number being multiplied by your function. So in this case, 6. So if this is -3, that means my amplitude has to be 6, which means I have to count up 6 from my midline. So 1, 2, 3, 4, 5, 6. And then I'm going to count down 6. 1, 2, 3, 4, 5, 6. So my max is going to be up here at y equals 3, and my min is going to be down here at y equals -9. So that's how I label my axes. So now I've labeled my y-axes, I've found my min and max, and now I'm good to go. All right, last but not least, you are going to follow the pattern for sine or cosine. So we are doing a cosine pattern. So cosine generally, so we kind of look at the origin. We shifted down 3, so we're going to go ahead to our midline. But then cosine starts at a max. So my first point is going to start at a max. My next point, which is at 1/8, is going to be at a midline. My next point, which is when x is 1/4, is going to be at a min. Then my next point, which is when x is 3 pi over 8, is going to be at a midline. And then my last point is going to be when x is 1/2, is going to be back up at a max. So remember, this is your maximum, so you don't want to go above that. So you're going to do one nice kind of big curve. And then remember, this is going to repeat forever and ever and ever, so it's going to go on forever and ever, like that. The last thing I want us to do is kind of answer a few questions about domain, range, and zeros. So what we're looking at here is we are looking at the domain of our function, so that means all of your x values that work. So because this is a continuous function from left to right, there are no x values that are excluded. So we would say this is all real numbers. So to write that in interval notation, you would just say -infinity to infinity. The range has to do with your min and max. So our lowest point at -9, our highest point's at 3. So you always start with your lowest y value first, and then your highest y value. And since we're including those values, we're going to go ahead and put brackets around. For the zeros, what you want to do is, and so the zeros are going to be any time it crosses the x-axis. So if we looked at this, 0 and 1/8, we got to figure out halfway between 0 and 1/8. Well, half of 1/8 is 1/16. So I'm going to say my first 0 is when x equals 1/16. And then when does it repeat? So if this is 1/16, 2/16, 3/16, 4/16, 5/16, 6/16, this is 7/16. So what it's repeating is that like the distance from here to here. So 1, 2, 3, 4, 5, 6, 7. Right? So it's repeating every 6/16, or in other words, 3/8. So it's repeating every 3/8. So what we do is we call that, we say 3/8 n. And the reason we do that is so that it shows that no matter, like, if n was 1, that means it repeats once. If it repeats twice, then it's like every multiple thereon after. And so I'm going to label my zeros as it's starting at 1/16, so I always kind of start with the first positive one, and then I go, well, how long did what was the distance between 1 0 and the next, and that's going to be how much they repeat. And so in this case, it was 3/8. All right, let's take a look at another graph. So this one is y equals -2 sine of pi over 4 plus 6. Okay, so on this one, we're going to start with the same way. We're going to start with by finding the period of your function. So it's 2 pi over b, and b is 1 in this case, so it's just 2 pi. So there's no b value, or it's 1. So I'm going to go ahead and label my x-axis. I'm going to do halfway, and then half of a half, or a quarter. So I've got my x-axis labeled. Okay, next step. Go back to my steps here. So I found the period. I'm going to use the period to label the x-axis. I'm going to plot the midline, and then I'm going to use the amplitude to go ahead and get the min and max. So the midline is at 6, so I don't have a lot of room here, so I'm just going to kind of estimate that that's up 6. And since my amplitude is 2, that means from the top, so 2 up and 2 down. So that means my min and max are between 8 and 4. So this is my midline, which was k value. So that was that value there. And since my amplitude was 2, remember you don't use the negative, it's like the absolute value of your a value. So then you would count up 2 and down 2. Okay, next we are going to shift this function. So there's a couple things going on here. So first of all, there's a shift right pi over 4. And then there's also a reflection. So the reflection just causes my graph to kind of, the pattern for sine or cosine just changes a little. Basically, every max becomes a min and every min becomes a max. And I'll show you how to do that in a minute. Let's first deal with this shift. So sine, we already shifted it up 6. Now we're going to shift it right pi over 4. Well, pi over 4 is right here. Okay, so this is pi over 4. So we are kind of off our points a little bit. So what we want to do now is, this is an example of a graph that you probably didn't graph last year because of the way this is written. It's a little bit more, this is a little bit more advanced. So rather than always having the 5 key points fall on those exact points, this time they're following halfway in between. So I'm just going to use a different color. I'm going to mark kind of halfway in between. So then I'm going to mark, this is going to be my point here is going to be my minimum. So because sine normally goes midline max, midline min, midline, but because of the reflection, we're going to go midline, which is my first point, min, my next point would be midline, max, and then my next point would be midline. So I'm going to go ahead and connect it. So again, the only thing I did here was I didn't get to use those exact, the 5 key points that I was labeling on the x-axis. I had to kind of go in between. So you got to be a little bit careful there. All right, domain. So the domain for all trig functions is going to be all real numbers. The range has to do with your max and your min. So my lowest value is 4, my highest value is 8. Your zeros are where the graph touches the x-axis. Well, notice that this whole function is going to be hovering above the x-axis. So that means there's going to be no zeros on that function. All right, let's graph another one. So this is 4 cosine of 1/2 x plus pi over 2 and then minus 2. I gave you this one in particular because this, again, is a little bit more advanced than last year. Notice that the number in front of here, it's kind of all jumbled in here. The first thing you have to do here is factor out the 1/2. In order for you to determine whether or not this function is shifted left or right, it has to be in the format, and if you look back at your original, it has to be in the format of x minus h, whether it's cosine or sine. It can't have a number or a coefficient in front of x. So if there is one, you have to factor it out. So that's what this would look like. So you would have y equals 4 cosine. So we're going to factor out the 1/2. So then if I factored out the 1/2, I would get pi, because 1/2 times pi is pi over 2, minus 2. So instead of graphing this function, we're now graphing the one above. So I had to factor out that b value first. All right, so on the side here, I'm going to do 2 pi over b. So 2 pi divided by 1/2. So that's 2 pi divided by 1/2 is the same thing as multiplying by 2. So that means I have 4 pi. Okay, use that to label your axis. So pick some distance. Let's go halfway. then quarter, and quarter. Okay, let's graph our midline, which is at -2. So now we know our K value is down here at -2. Our amplitude is 4, so this would be back up to 0. So our amplitude, 1, 2, 3, 4, so this would be at -6. So our max is at 2 and our min's at -6. Again, I just counted 4 up from my midline. All right, we are going to shift this function. The plus pi means we're moving left pi. So we're going to start to the left. So I need to add in some points here. So I'm just going to extend my pattern. So I'm going to start at a midline. It's cosine, so I'm going to start at a max, but I'm going to start left pi. So I'm going to start right here. That's my first point. So this is my first point. 0 would be my second point. So it goes cosine would be a maximum, then a midline. My next point would be at a min. My next point would be at a midline. And my last point for those 5 key points would be at a max. And that's what I get for my function. So again, cosine always starts at a max or a min, depends on if it's reflected. And since we had to go left pi, we started up here at a max, but it was shifted over to the left. And then I just followed the pattern for cosine. Max, midline, min, midline, max. And that was it. Let's see. That's all I have for graphing. I tried to give you some examples that were a little bit more challenging than the traditional basic ones. So what I would encourage you to do is to practice this, and then if you have questions, to bring them to class. All right, that's it for now. Bye, guys.